And in the case of what we have for proportions, and again, proportion is going to be a statement of equality, okay, between ratios or rational expressions. And for what we have in the case of proportions, okay, so for what we have in the case of proportions, okay, so we have by definition, okay, for proportions, okay, we have that if we have a statement of equality between two ratios, say we have A over B is equal to C over D, and if that statement is true, okay, then you're going to have what will be referred to as proportional cross products, where you have taken the product of alternating numerator and denominators. And so we have A times D is equal to B times C, and this would be with the restrictions, okay, that the denominators be non-zero in value. Okay, so if A over B is equal to C over D, then we have the proportional cross products A times D equal to B times C, with the stipulations that neither B nor D be zero. And now let's say that in the case of what we have as an example of a proportion, and say if we have looking at solving for x, and we have here, let's say we have 2 over x plus 4 is equal to 1 over x minus 3. And for what we have in the case of the restrictions, okay, so we do not want zero-valued denominators. Okay, so x plus 4 cannot be 0. So we have that x cannot be negative 4. And for x minus 3, okay, this cannot be 0 either. So we have that x cannot be equal to 3. So whatever we have for x, we want the solution to be such that we will not end up with negative 4 or 3. And so just looking at taking what we have with the proportional cross products, okay, so if I multiply out, okay, so you have 2 times, okay, the quantity of x minus 3, and we can say is equal to 1 times the quantity of x plus 4. So I'm just mapping together the A and D as well as the B and C items. And we have with distribution, okay, so we have on the left we have 2x minus 6, and to the right again we have equal to x plus 4, and here we have pairs of like terms on opposite sides of the equation. Okay, so let's say if I combine x terms together, so you have 2x and x, and if I proceed by taking out the smaller variable term, which in this case is going to be x, alright, so we're going to have the left hand side will be transformed to x minus 6, and that will be set equal to 4. And if x minus 6 is equal to 4, and I add 6 to both sides, well, we have for the value in x, okay, that is equal to 10. And we have 10 to satisfy both restrictions, okay, not being equal to negative 4 or 3. And for this type of statement, you can sort of go back and check. We have with x at 10, 2 over 10 plus 4 will translate out to 2 over 14. And 2 over 14 is reducible to 1/7. And for what we have to the right, we have 1 over 10 minus 3, and that is also 1/7. So x equals 10 will check out. And for radical equations, there's one key property I do want to mention. That's going to be in reference to even root radicals. And this will be for what we have regarding the principal square root rule. Okay, and for the principal square root rule, okay, this is going to state that the square root and not just the square root, but textbooks commonly refer to just the square root, but it carries out to even roots, period. Okay, so I have square root, fourth root, sixth root, and so on. And again, square roots, it's implicit that what's referred to as the number of the root, that's going to be 2, but 2 is not usually on display. And for the principal square root rule, we have that the square root of an expression cannot reduce to a negative constant. And I'll just mention at the start. Okay, so we have the principal square root rule. Let's call this PSR. It's going to apply to even roots only. Like it would not apply to cubic roots or fifth roots or seventh roots. And let me give you just kind of a backdrop to the principal square root rule. Now, it's kind of a cousin, but it's not the same thing as what we had back when we were looking into the square root property of equality. Now, when you had an equation, let's say like x squared is equal to 36. Again, for that number 2 from x squared, you have possibly 2 solutions. And if we start out with the equation in the form of like x squared is equal to 36, and I applied the square root property of equality, so going from x squared to x, we have plus or minus, okay, the square root of 36. So we had the x equal to plus or minus 6, and so we have for the solutions in x, you would have 6 and negative 6. But now where the principal square root rule would be addressed, let's say just as a cousin to this particular problem where the follow-through was with the square root property of equality. If we have, like in the case of solving for x, if we had, let's say, x is equal to the square root of 36. Okay, if you notice, we don't have x to be of second degree from the start. It's just a first order, so likely there's going to be only one solution. And so with x equal to the square root of 36, okay, again, square root of 36, like if you were to enter 36 into your calculator and then take the square root, okay, x would end up going to 6. And if we have something like x is equal to the square root of 100, Okay, so in this case, x would be equal to 10 only. And let's say that if I had something like, just in the case of, let's say if we have x in the square root. Okay, so you have like the square root of x plus 4 is equal to 7. Okay, so we have the square root of an expression. Okay, like the square root of 36 does not reduce to a negative constant. The square root of 100 does not reduce to a negative constant. So we had respective solutions at 6 and 10. But let's say we have x inside the radical, whereupon we have the square root of x plus 4 is equal to 7. So we have the square root of an expression, and this reduces to 7, and 7 is not negative. So we're going to have at least a solution for x. And so what I can do here is that I can take care of the square root portion if I take both sides and square. So the square root of x plus 4 squared, again the exponent and the radical will take care of each other. To the right I have 7 squared is equal to 49. And if we have the x plus 4 is equal to 49, well, our solution in x, okay, that is going to end up at 45. And say we have just like added cases here. If I have, let's say, so you have the square root of 2x plus 5 is equal to negative 3. And guess what? We still have an even root with the square root of 2x plus 5. And guess what? This square root, still an even root of an expression. It cannot reduce to a negative constant. You notice negative 3 is in violation. It's because of the negative sign that we have automatically for x, there will be no solution. And just kind of re-entering, if I have, let's say, the cubic root of 2x plus 5 is equal to negative 3. Again, we have an odd root this time around. And again, the principal square root rule does not apply to odd roots. It applies to even roots only. So in this case, I can free up 2x plus 5. And cubic roots can be undone by taking the radical and cubing out. So I'm going to apply both sides and cube out. So here we're going to have 2x plus 5 is equal to negative 3 cubed. And negative 3 times itself. This would be negative 27. And so for what we're going to have here, taking 5 away from both sides, so you have it 2x is equal to negative 32. And if I divide both sides by 2, it's going to turn out that the value for x is going to be at minus 16. Okay. And tell you what, just for the next few moments, okay, if we look at solving for x, And we'll say that we have here let's say x is equal to the square root of 400. And we'll say we have the square root of 2x minus 4 is equal to 3. And we'll say we have the square root of x plus 2 is equal to negative 10. And we'll say we have the fifth root of 3x plus 7 is equal to 1. Okay, for what we have in the case of trying to solve for x, okay, so we have in the first item we have x by itself in the set equal to the square root of 400. Now 400 is a perfect square value, and again the square root of an expression cannot reduce to a negative constant, and so with the square root of 400, okay, that is going to be 20 only. Now for what we have in the second equation, now we have the square root of 2x minus 4, okay, is equal to 3. Okay, so we had the square root of an expression, in this case the expression 2x minus 4 reduces to positive 3. So there is room to work and find a solution for x. So if we look at squaring both sides, okay, so left hand side becomes 2x minus 4. And we have the 3 squared is equal to 9. Okay, so here we have a two-step linear equation. So if I add 4 to both sides, and I have that 2x is equal to 13. Okay. What do we have for x? Okay, we have a non-integer value. In this case, x be equal to 13 halves if you leave as a fraction, or as a decimal, okay, we have 6.5. Okay. And you can go back and check. So 2 times 6.5 is 13, minus 4 is 9, square root of 9 is equal to 3. Now, for what we have in the third equation, we have an even root radical, but this is said to reduce the expression to negative 10. And since we have a negative value here and we're working with an even root radical, this means we have no solution. Okay, and for what we have in the last of this particular set, we have the fifth root of 3x plus 7 equal to 1. Okay, and if I had like negative 1 to the right, I could still work with this radical since this is an odd root. And now I can take care of the radical, again, taking both sides and raising to the power that matches the index number of the radical. In this case, this will be 5. Okay, so if I take both sides and raise to the 5th power, okay, so I'm going to have 3x plus 7 is equal to 1 to the 5th, which is still going to be at 1. And then we have just following through. If I isolate the x term, upon taking 7 away from both sides, so I'm going to have 3x is equal to negative 6. and we have with division by 3, okay, we come out to x equal to -2. All right, now I'll give you a couple more special cases. One of which is going to be where you might have numerical coefficient out in front of the radical. And I'm going to show you just a couple of ways for this one. And let's say that if you have 4 times, okay, the square root of x plus 1 is equal to 7. Okay. What I can do here, I can isolate the radical upon dividing both sides by 4. Okay, so I had the square root of an expression going to positive 7/4. Okay, so we're going to have at least one solution for x. So I can take care of the radical upon squaring out both sides. So the square root of x plus 1 squared, this will become x plus 1. 7/4 squared, 7 squared is 49. 4 squared is 16. And if I get x by itself, so I'm going to take 1 away from both sides. So you have 49/16 minus 1. And if I write this as a difference of fractions, now remember, think of like minus 1 is like minus 1 over 1. Least common denominator will be 16. And so 1 will go into 16 times. So subtracting 1 will be the same as subtracting 16/16. And so for x, I would have 33 over 16. This is one approach. Let me show you the other. Let's say that you don't want to work with fractions from the start. What you can do instead is go ahead and square both sides out. But there's a slight catch to this. Upon squaring both sides, now 4 squared is 16. Square root of x plus 1 squared is going to be x plus 1. Now 7 squared is going to be 49. Okay, now here's the catch. Okay, now if I square what I have here, it's not going to go to the binomial 16x plus 1, because while we have squared the factors, the squaring does not automatically take care of the multiplication that is entailed. So you have not 16x plus 1, but 16 times all of x plus 1. So here, we squared the factors, and then following through completely with distributing 16 all over the quantity of x plus 1. So I'm going to have 16x plus 16 is equal to 49. And guess what? Taking 16 away from 49, so I have 16x is equal to 33. And we have with division by 16, okay, we have, with this approach, we have x to come out to 33 over 16. Okay, so different pathways, but still leading up to the correct solution. And now, if I have, let's say, a couple of expressions in x, and let's say if we have looking at solving for x, and this is going to be a reminder that we have regarding the square root property of equality. And we'll say that we have x is equal to the square root of 4x plus 12. So I have, looking at solving for x, so x is equal to the square root of 4x plus 12. Okay, now if I square both sides, okay, so left side I still have x squared. To the right, we have 4x plus 12. If you notice, we have a quadratic equation that is established. And if I take what I have and write in standard form, so I'm going to join x squared with the first order and constant terms. So we're going to have here, we have x squared minus 4x minus 12 is equal to 0. And looking at factoring, so for x squared, this will go to x and x. Factors of negative 12, whose sum or difference will be minus 4. So we have x plus 2 and x minus 6. And applying the zero product property, one apparent solution for x will come from setting x plus 2 equal to 0, where we have x equal to negative 2. And for x minus 6 equal to 0, then we have the other possible solution for x. We had to be at 6. And now, with even root radical expressions, you don't have to write it out, but if you check your results here, say if I check x equal to negative 2, again, this is our equation. Okay, so you have like x at negative 2, you have equal to the square root of 4 times negative 2 plus 12. 4 times negative 2 is negative 8. And negative 8 plus 12 is going to be 4. And guess what? Square root of 4 is going to be at 2. And we're trying to say that negative 2 is equal to 2, so that is going to be false. And you already have with negative 2, you already have the violation of the principal square root rule. So negative 2, that's going to strike out. Now, as for what we have in the case of x is equal to 6. Okay, so we got the same equation, different value of x to plug in. Okay, so you got x at 6. Then we have the square root, and we have 4 times 6 plus 12. Four times 6 is 24, plus 12 is 36. It's kind of showing you incrementally, step by step. Now the square root of 36 goes to 6. And we have that 6 is equal to 6. So x equals 6. Okay, that is going to check out. So for this particular type of equation, okay, we have only one solution, and that is going to be with the number 6.